Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Course 3, Lesson 2-3, Comparing and Ordering Rational Numbers. Here we're going to look at using least common denominators, decimals, and number lines to compare and order rational numbers. Okay, so to begin with, we do have a couple of vocabulary entries that we need to be concerned with. The least common multiple, LCM, of two or more numbers is the least multiple common to all of the numbers. Okay, so it's the smallest multiple that when you list out multiples of the numbers, it's the smallest one that they have in common or that they share. So least common multiple. A companion to that is the least common denominator, or LCD, of two or more numbers. And it is the least common multiple of the denominators. When dealing with fractions, basically, when we have to find a common denominator, we're actually looking for the least common multiple of the denominators, therefore, least common denominator. Okay. All right, so our first question is asking us to compare using the least common denominator, or LCD. Which is greater, 7/18 or 5/12? So you can list the multiples of each of the denominators to find their LCD. So we see that the multiples of 18 are 18, 36, and so on. It continues. But you don't have to keep going unless you really need to. So I always try to do a couple at a time for each one. Multiples of 12 are 12, 24, and 36. So we see that their least common denominator, the smallest multiple that they share, is 36. So that's going to be the LCD for these two fractions. Okay, so we're going to change, the LCD is 36, so we're going to take 7/18 and multiply both the numerator and the denominator by 2. 2 over 2 is another name for 1. So we're really just multiplying by 1, just a fancy name for 1, not the regular everyday name for 1. 7 times 2 is 14. 18 times 2 is 36. So we can rename 7/18 as 14/36. We'll follow a similar process for 5/12. 12 times 3 is 36, so we're going to multiply both the numerator and the denominator by 3. So when I do that, 5 times 3 is 15, and 12 times 3 is 36. So 5/12 is renamed as 15/36. Since 15/36 is greater than 14/36, 5/12 is greater than 7/18. And generally we do want to go back and answer the question using the original numbers in the question. This tells you how to answer the question. This in fact answers the question. Okay, so at this point you can either pause and do the quick check or come back to it later, whichever you prefer. Okay, we're going to go on to the next page to example number 2, which is comparing using decimals. Let me get this focused for you. There we go. All right. The Eagles won 7 out of 11 games, while the Seals won 8 out of 12 games. Which team has the better record? Change each fraction to a decimal and compare the two decimals. So in this case, it's a different approach to comparing these fractions. So we can write their fractions. Eagles, 7 wins out of 11 games. Take 7 divided by 11. You may use a calculator. And you get 0.63 repeating. So the 6 and the 3 repeat. So similarly, 8/12 is equal to approximately 0.66 repeating, where the 6 is repeating. And we would write that with our bar notation for both of those. As you see, the next step, your book took the authors took the rounded numbers, which is perfectly fine. 0.666 repeating is greater than 0.363663. Oh, I'm sorry, I didn't say that very well. 0.6363 and so on. Okay, since the 0.6 repeating is greater than the 0.63 repeating, the Seals have a better record. Okay. Another thing we can do with this is ordering rational numbers by using the number line. Okay, so we have negative 0.175, 2/3, negative 5/8, 1.7, and negative 0.95. We want to order them from least to greatest. Okay, so we have 1, 2, 3 decimals and 2 fractions. So what we'll do is we'll change the fractions into decimals. It's probably the most efficient way to do this most of the time. 2/3 gives you the 0.6 repeating. Negative 5/8 is negative 0.625. And then we'll utilize those and graph them on our number line. Okay, so as I went and graphed these, I checked off what I had graphed. Negative 0.175, 2/3, which is right here. Negative 5/8, which is right here. 1.7 over here. So I'm going to check it off. And negative 0.95 way over to the left. Okay. What this does, it lays out your the values of these numbers from least to greatest on the number line. Okay. So negative 0.95 is less than negative 0.625, which is less than negative 1.7. Then, excuse me, let me start that one over. Negative 0.175, which is less than 0.6 repeating, which is less than 1.7. Again, this gives you the answer with all the decimals, so you go back and write it with the numbers that were given in the original problem. And this is how I want you to answer. I want you to answer with the numbers that you initially began with, even though you had to do some conversion in order to get to this point. Okay, I'm finished with notes for this section. Please be sure that you do complete the 3 quick check questions before next coming to class. I look forward to seeing you then. Thank you.